Hi there and welcome to Mr. Arnold's Maths. In this video we're going to look at the Further Mathematics Level 2 certificate which is just started this year by AQA, and I'm looking at practice paper set 2. We're looking at paper 1, which is the non-calculator paper, so I'm going to work through all the questions here. Right, start out. Question 1 gives us y equals 2x cubed minus 5x, and we're asked to work out dy dx, so to differentiate. So dy dx equals, okay, so you take the power down in front, multiply by the coefficient, and drop your power by 1. 3 times 2 is 6, so we get 6x squared, so dropping your power by 1. And then minus 5x, when we take the derivative, is minus 5. So handy 2 marks there. Question 2, we're given a linear sequence, and we're asked to work out an expression for the nth term. Looking closely at it, we can see that it's a basic linear sequence going up in 7, so it's going to be 7n, and then we compare the 7 to the 4. How do I get from 7 to 4? I take away 3. Really quick way of doing that. How many terms are less than 150? So I want to solve this inequality, so I want to know where 7n minus 3 is less than 150. So that tells me that 7n must be less than 153, and dividing by 7 we get n is less than 21 remainder 6. So where is n less than 21 remainder 6? Well, it must be 21. So 21 terms are less than 150. If you want to check it, substitute it back in and see how it works out for you. Right, question 3. We're given two number machines with the same input x, and we're asked to work out what x is. Well, I don't like number machines like this, so what I'm going to do is I'm going to turn it into an equation. So we take x, we multiply it by 5, that gives me 5x. We add k to it, we add k, and then the output is 3. Okay, so there's the first one done. The second one gives me x times 3 is 3x. We're taking away k, and then the answer is 1. And hopefully you can see straight away it's a simultaneous equation, and it's nicely done for us. We're going to add equation 1 and equation 2. Equation 1 plus equation 2 gives me 8x equals 4. Therefore x must be equal to a half. So x is a half. If you want, you can check it out by substituting back in. Right, question 4 gives us a transformation matrix, and it tells us that it maps the point 3, 4 onto the point 2b, and we're asked to work out the values of a and b. So just some matrix multiplication here. So we have a, 2, minus 1 and 1, and it maps the point 3, 4. So when I multiply it by the point 3, 4, which I'm going to write as a matrix, it should give me the point 2b. So let's do some matrix multiplication here. So to work out the top column, in fact, just to backtrack a little bit, it's a 2 by 2 matrix, and it's multiplied by a 2 by 1 matrix. So these are the same, which means we can multiply, and which tells me my answer will be a 2 by 1 matrix. So it's going to be a 2 by 1 matrix. Okay, so we go a times 3 is 3a, 2 times 4 is 8. So the top is going to be 3a plus 8. And then underneath, minus 1 times 3 is minus 3, plus 1 times 4 is 4. Minus 3 plus 4 gives me 1. So that must be equal to that, 2 and b. Right, so we can see straight away that b must be equal to 1, and 3a plus 8 must be equal to 2, which means 3a must be equal to minus 6, which means a must be equal to minus 2. And that's how it's done. So some matrix multiplication there for you. Right, next question. We're asked to work out the value of tan of x, so using triangle A, B, C. Right, so tan, just a reminder, tan of an angle is the opposite over the adjacent. The opposite in this case is 4. The adjacent is 12. So 4 over 12, which is the same as 1 over 3. So tan of x is 1 over 3. And the next part, we're asked to work out the length of PQ. Right. So what do we know already? We know that using the big triangle, the whole triangle, tan of x equals 1 over 3. So we worked it out from the previous part. But what if I use the tan for this angle? Well, tan of x, I'm going to call this, by the way, I'm going to call it y. Tan of x must be equal to y over 7. But these two ratios are exactly the same. So I can equate them both. So it's 1 over 3 must be the same as y over 7, which means y must be equal to 7 over 3, which equals 2 and 1/3. This question, by the way, is nearly identical to the question in practice paper set 1, using tan as well. Right, question 6. Expand and simplify. So just some basic algebra here. So 5x times 4x is 20x squared. 5x times 3y is plus 15xy. Minus 2y times 4x is minus 8xy. And minus 2y times 3y gives me minus 6y squared. And tidying up, we get 20x squared plus 7xy minus 6y squared. And that is question 6 done. Question 7. So it tells us that P triangle T is defined as all of this. And it gives us an example of how it works. So we have this new mathematical operation, let's call it triangle. And it's defined as doing all of this. And we're asked to work out what 4 triangle minus 3 is. Well, we just substitute in. So we're going to get 3. By the way, this represents the P and this represents the T. So the only thing to watch out for here is your signs. Be careful with signs. 3 times 4 squared plus 4 minus 3 squared minus 3. So I've just put up some brackets here to help protect the negative signs and make sure I do things correctly. Right, 4 squared is 16. 16 times 3 is 48. And we're adding 4 to that. And then we're going to take away minus 3 squared is 9. And then we're going to add 3. And then when you tidy all that up, you get 46. Job done. Right, here's the tricky one. So we're asked to work out all the solutions of x triangle 5 equal to 0. So I'm going to start by substituting x and 5 into this and let that equal 0. So we get 3x squared plus x minus 5 squared minus 5. And that should be equal to 0. So that means 3x squared plus x minus 25 minus 5 should be equal to 0, which tells me that 3x squared plus x minus 30 should be equal to 0. Okay, so we're going to factorize now. And when we factorize, we get 3x plus 10 and x minus 3. And that should be equal to 0. So we've got the product of two terms equals 0, which means one or both must be equal to 0. So setting up two equations, 3x plus 10 equals 0, which means 3x equals minus 10, which means x equals minus 10 over 3. And this second equation, x minus 3, must be equal to 0, so x equals 3. So the answer is minus 10 over 3 and 3. Okay, flying along here. Right, question 8. We're told the equation of line L is 2x plus y equals 3. Now, it tells me that line M is parallel to line L and passes through that point. And you're asked to work out the equation of the line M. Right, for starters, I'm going to take this equation and get it in the form y equals ax plus b. Or you might be more familiar with y equals mx plus c, where m is the gradient. So taking this, we'll do it over here. Line L is actually y equals minus 2x plus 3. So that's the equation of line L. Now they're both parallel, which means they have the same gradient. So I know the gradient. I know that m equals minus 2. So the gradient is minus 2, and I have a point. So I'm going to use this formula here. And it's important you know your formula before you sit this exam. So the formula for the equation of a line, when you have the gradient and one of the points, is y minus y1 equals m times x minus x1. x1 and y1 are the point that you're going to use, and then y and x are just, they're part of the equation, they're part of your actual answer, so leave them alone. Right, so we get y minus, y1 is minus 6, so it's minus minus 6, which is plus 6, equals m, which is minus 2, times by x, minus x1, which is 1. So just in case, I'll label that, that's x1, and that is y1. So that's what I've been substituting into my formula. Right, tidying up, y plus 6 equals minus 2x plus 2, which means y equals minus 2x minus 4. That's question 8a done. Right, it tells me that the line N is perpendicular to the line L. Perpendicular. Now that's important and passes through that point. We're asked to work out the point of intersection with the line N and the x-axis. Right, let's start by working out what the equation of the line N is. Well, if N is perpendicular, that means the gradients, when multiplied together, if I multiply the gradient of N and I multiply that with the gradient of L, the answer should be minus 1, okay? Now, generally, what most of us learn is that you just flip the gradient upside down and change the sign. It was minus 2, so that was minus 2, which means the gradient for N must be a half. So flipping it upside down and changing the sign. Right, so I know the gradient. The gradient is a half, and I know that a point is minus 5, 4. So that's x1, that's y1. Right, so let's substitute. So we get y minus y1 equals m times x minus x1. Minus minus 5 gives me plus 5. Right, let's multiply that out. Y minus 4 equals a half x plus 5 over 2. You can leave that as 2.5 if you like, or 5 over 2, whatever you want. Now what else do I know? It's the point of intersection with the x-axis. What does that tell me about the line? Well, when the line hits the x-axis, so any line at all, when it hits the x-axis, doesn't matter where it is, I know that the value of y is 0. The value of y must be 0. So I'm going to substitute y equal to 0 in here. So we get 0 minus 4 equals a half x plus 5 over 2, which means minus 4 equals a half x plus 5 over 2. Multiply across by 2, we get minus 8 equals x plus 5, which tells me that x must be minus 13. So I know that this line, the line N, crosses the x-axis at the point minus 13, 0. A little bit tricky, that one. Really, really important though, guys, that you understand and you know your formula. You have to know your formula to answer that question. Okay, we're asked to simplify fully. We've got 3x over x minus 3 times x plus 6 minus 2 over x plus 6. Well, we need to use the lowest common denominator. We need the lowest common denominator. The lowest common denominator is, in this case, it's going to be x minus 3 times x plus 6. That's the lowest common denominator. So this expression here is going to stay as the same. Now, I want to turn this x plus 6, I want to make it now x plus 6 times x minus 3. So what have I done? I've multiplied the bottom by x minus 3, so I'm going to multiply the top by x minus 3. That way I haven't really changed it. Right, so we've got a common denominator, which means we can just subtract the top as normal. So we get 3x minus 2 times x minus 3, and that's all divided by x minus 3 times x plus 6. Okay, expand out the brackets on the top. We get 3x minus 2x is going to give me x, and minus 2 times minus 3 is plus 6. So we've got x plus 6 all over x minus 3 times x plus 6, and lo and behold, the top cancels out with that, and leaving me with 1 over x minus 3. Right, moving swiftly on. Question 10. We're asked to make y the subject of the formula. Now this can be quite tricky, but there's still marks to be had for having a go. 5 marks. So I'm going to start. I don't like this square root sign. Let's square everything. So we get x squared equals y plus 1 over y minus 2. Okay, so we're squaring. Right, I do not like to have y's underneath the line, so we're going to cross multiply. Cross multiply. Right, so x squared times this gives me x squared. Right, we'll just write it as this, x squared times y minus 2. So we're cross multiplying. And this is still just y plus 1. Okay, now we're going to expand. Right, so we get x squared y minus 2x squared equals y plus 1. Now we're going to gather terms. Right, what we want to do is we want to get everything that involves a y over to the left hand side and everything that doesn't have a y over to the right hand side. This has a y, so leave it alone. X squared y. I'm going to bring this y over, so take y off both sides. And I'm also going to add 2x squared to both sides. So we get 2x squared plus 1. Now we're going to factor out that y. So you get y times x squared minus 1 equals 2x squared plus 1. And then finally divide both sides. Divide both sides by x squared minus 1. So we get y equals 2x squared plus 1, all divided by x squared minus 1. So x squared minus 1. And that's it. Job done. Okay. Question 11. We're asked to show clearly that sine 45 is 1 over root 2. No problem. Okay, this is a right angle triangle. That's the opposite. That's the adjacent. This must be the hypotenuse. Let's see what Pythagoras said about the hypotenuse here. So h squared should be equal to 1 squared plus 1 squared, which means h squared must be equal to 1 plus 1, which is 2, which means h equals root 2. So we know that h is root 2, and sine 45 equals the opposite over hypotenuse, which is 1 over root 2. Nice and handy one, that. Alright, question 11. Work out the value of theta. Right, so we got theta here, and we got the opposite side. We got an angle here and the opposite side. Now, the fact that we have angles and the sides opposite should scream to you that you need to use the sine rule. So we're going to use the sine rule. So I know that sine of theta divided by root 3 must be equal to sine of 45 divided by root 6. Okay, sine of theta, I'm going to multiply both sides by root 3, must be equal to root 3 multiplied by sine 45. And instead of writing all divided by root 6, I'm just going to write it as multiplied by 1 over root 6. It's exactly the same thing, but you'll see why shortly. Sine theta is going to be root 3 multiplied by, well, sine 45 we know is 1 over root 2. We worked that out in the previous one, and that's multiplied by 1 over root 6. Right, 1 over root 2 by 1 over root 6, 1 over root 2 multiplied by 1 over root 6 is actually 1 over root 12. So you have to be pretty decent with your surds here. 1 over root 12. And root 12 is the same as root 4 times 3, which is the same as 2 root 3. So root 12 is 2 root 3. So we end up with sine theta is root 3 over 2 root 3. The 2 root 3's cancel out. Root 3 cancels out with root 3, and we get 1. So you get sine theta is a half, and you need to know that if sine theta equals a half, that means that theta equals 30 degrees. So you need to know your trig functions, 30, 45, 60 degree angles, 90 degree angles, all that sort of stuff for sine, cosine and tan. Okay, that was a tricky question. Right, question 12. Now there's two ways of doing this I've discovered, and I'll show you both. So let's start out with the first way I attempted it, which was basically a little bit of substitution. Well, what are we told first? A diagram shows a sketch of this circle, and it tells us the center is C, and it says the line y equals 6 intersects at these 2 points, and we're asked to show that the length of this line is 2 root 5. Okay, well, before I even started this question, I thought, well, what do I know about the circle? I know from the equation of the circle that the center must be 7, 4. 7, 4. And that comes from the general formula of the equation of a circle. I also know that the radius is 3. Okay, so that must be the radius must be 3, because that value is r squared, so r must be equal to 3. So I know that that distance is 3. Alright, where do we go from here? I also know that at this point here, y is 6. And at this point here, y is 6. I would really like to know what x equals at this point. If I know what x equals here and x equals here, I can take the difference away, and that will tell me how long that line is. So I'm going to substitute y equal to 6 into there, into the equation, and work out what x would be. So we get x minus 7 squared plus, let's write it out in full, 6 minus 4 to be squared must be equal to 9. So we get x minus 7 squared. 6 minus 4 is 2. 2 squared is 4. So plus 4 must be equal to 9. That means x minus 7 squared equals 5. Should be a little bracket here. X minus 7 squared must be equal to 5, which means that x minus 7 should be equal to plus or minus root 5, which means x equals 7 plus or minus root 5. So I know that x is 7 plus root 5 or 7 minus root 5. So this one would have to be 7 plus root 5. Why? Because it's going to be bigger than 7 minus root 5. Because that is closer to the origin than that. So that's 7 plus root 5, that's 7 minus root 5. And if I want to know the difference between them, I'm going to do 7 plus root 5, and I'm going to take away 7 minus root 5. Okay, now it's imperative here that you watch out for the signs. I'm actually taking that away. 7 take away 7 is 0, so they're gone. And 5 minus root 5 is actually 2 root 5. And there you have it. I've shown that AB is 2 root 5. Alright, let's show you method 2. This method is actually I came up with after, and it's actually quite elegant. I like it, and it's quicker in my opinion and easier. Right, so just going back to what we learned before, we know that that distance we know must be 3 because that's the radius. Now, if I draw a perpendicular line straight up to cut there, it will bisect AB. It will cut it in half. But what have I formed here? I formed a right angle triangle. So I now know a right angle triangle. What else can I tell? Well, I know the center. We talked about this earlier. I know that the center of this is 7, 4. So that's 7, 4. So the y value here was 4. And when it gets up to here, it's 6, which means that the distance must be 2. So that distance is 2. So I now know 2 pieces of the puzzle. If I work this out and then double it, that tells me the whole distance. So using Pythagoras, that's the hypotenuse. So that's the hypotenuse. Let's call it h. And this doesn't matter. We'll call it a or o, whatever you like. A for adjacent or o for opposite. Doesn't matter because we don't have an angle of reference here. We get h squared. So 3 squared should be equal to 2 squared plus o squared. Right? O squared is this piece we're looking for here. So that's what we're trying to work out. That's O. Right, which means 3 squared minus 2 squared equals O squared. 3 squared is 9. 2 squared is 4. That must be equal to O squared, which means O equals the square root of 5. So I know from there to there is root 5. So I know that a half of AB equals root 5, which means that AB equals 2 root 5. And that, I think, is a little bit easier, but you have to be able to spot the trick with the distance and the right angle triangle. Okay, question 13. Now, there's about 5 or 6 ways to do this question. I'm just going to show you one, and you can have a go, see if you can work out your own way of doing it. I started by multiplying both sides by root 3. So, we get root x times root 8 equals 4 times root 5 times by root 3. 4 root 5 root 3. Let's start to tidy things up a little bit. Well, root x times root 8 is the same as the square root of 8x. And root 5 times root 3 is the same as root 15. Now if I square both sides, we get 8x equals 16 multiplied by 15, which means that x is going to be the same as, I'm actually going to divide this by, divide that by 8, divide that by 8, and we're good. So it's the same as 2 times 15, which means that x is equal to 30. Nice handy way of doing that question. Now there's many more ways of doing it. You can try and see if you can find the other methods. Right, question 14. X minus 5 is a factor and we're asked to work out A. So this is a factor theorem question. Now what do I know about the factor theorem? I know that if f of, sorry, I beg your pardon, if x minus k is a factor, that means that f of k should be equal to 0. It must be. So if x minus 5 is a factor, that means f of 5 should be equal to 0. So if I substitute 5 in here, it has to be equal to 0. So let's go and do that. So we get 5 cubed minus 6 times 5 squared plus a times, oh, beg your pardon, let's write that as 5a, plus 5a minus 20, and because it's a factor, the factor theorem tells me it must be equal to 0. 5 cubed is 125, minus, well, 5 squared is 25, 25 times 6 is 150, plus 5a minus 20 must be equal to 0. So 5a, tidying up, that's minus 25, minus 45, so it should be equal to 45, which means that a must be equal to 9. And that's it. A is equal to 9. Right, question 15. We're asked to show that the tangents at P and Q are perpendicular. There's that word tangent again. Came up in the last video. We should start to think dy dx. I probably have to do something with the derivative of y with respect to x. Okay, so let's differentiate this. Well, it's difficult to differentiate like that unless you know your product rule, but you don't need to know the product rule, so I'm just going to expand it out. So y equals x squared minus 5x plus 6. So that's what y is. That means dy dx should be equal to 2x minus 5. So dy dx is 2x minus 5. So that's the gradient function of the tangent to the curve. Right, and we're asked to show that they're perpendicular at P and Q. Well, what is the value of x here at P, and what is the value of x here at Q? The value of x here must be 2, because I can tell straight from this it must be 2, and from here it must be 3. One of the reasons I know this as well is because y on this line here, on this x-axis, y must be equal to 0. So y equals 0. So I would have effectively an equation here. 0 equals x minus 2 times x minus 3. And solving for x for both, you get x is 2 and x is 3. So I know what the value of x is here and here. So what I'm going to do is I'm going to evaluate the gradients at these points and see if they're perpendicular. If they're perpendicular, when I multiply them together, I should get minus 1. So let's do dy dx, and I'm going to evaluate at x equal to 2. So you get 2 times 2 minus 5. 2 times 2 is 4. 4 minus 5 is minus 1, should I say. Minus 1. And next one, I'm going to do dy dx evaluated at x equal to 3. And we get 2 times 3 minus 5. 2 times 3 is 6. 6 minus 5 is 1. Well, let's check. If I multiply 1 times minus 1, do I get minus 1? Indeed I do, which means, therefore, they are perpendicular. Regular. All right. And the final question of the paper, we're asked to prove that n plus 2 squared plus n plus 1 squared minus 1 is always a multiple of 4. Well, a good start to make with these questions is just to expand your brackets. So n plus 2 squared is going to give me n squared plus 4n plus 4. And I'm going to add, expanding this now, n squared plus 2n plus 1, and then we're taking away 1. So tidying all that up, we get 2n squared, 4n, and 2n is plus 6n and plus 4. So that's what we have there. That looks very familiar to me. It looks like a quadratic. And before I factorize a quadratic, I'm going to factor out that 2 because everything in here is divisible by 2. So we get n squared plus 3n plus 2. So let's factorize this quadratic. So we get 2 times, and when you factorize that, you get n plus 2 and n plus 1. And we've actually done the bulk of the work there. If you look at this part, one is n plus 2, one is n plus 1. So they are consecutive. Consecutive. My spelling is dreadful here. They're consecutive, which means one is odd and one is even. And that doesn't matter. One of them is definitely odd, one of them is definitely even. And we know that odd times even is always even. So I know that this part, right, this whole thing here, must be even. Okay, and if you double any even number, 2 times any even is always divisible by 4. 2 times any even is always divisible by 4. If you think about it, let's pick 8. 8 times 2 is 16. 16 is divisible by 4. The reason is because you can divide an even number by 2, and then you can divide that by 2, so it's divisible by 4. And that's it from me. So that's the second set of exam papers I've done. Hope you enjoyed the video. Some tough maths in there. If you have any questions, feel free to comment, and best of luck with the studying. I'll talk to you again sometime.